All right, so we're just going to graph three basic logarithmic functions today with base 2, 4, and 3 respectively. We're going to start with 2, okay? So when you're plugging values in for x, we have to take log base 2 of it, all right? So let me go ahead and rewrite this as an exponential real quick. So 2 to the y is going to equal x. Okay, so what we need to plug in for x are values that we can see over here. Because these are all 2 to the y's. Going from this, I'm showing you the chart that I've sent out several times, but from this chart, 2 to the y's over here, these are all my x's over here. So if I put that over that, maybe that makes it easier. I'm trying. Anyway, that won't fit on my graph, this won't fit on my graph, but 16 will. So I'm going to plug in 16 for x, since it's on the right side over here. So if you have 2 to the y is equal to 16, what should y be? Well, if it's 16, y would be 4. So 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 1, 2, 3, 4. So there's my first point, 16, 4. Now, if I go back to the very beginning and look at this, I have to think, okay, whatever numbers I put in for x have to be good numbers that work with x. Numbers that are not multiples of 2, because that would just be even numbers, but that exist over here as powers of 2, if you will. So the next number I'm going to plug in for x should probably be 8. Be a good idea to use 8. Because if I change this, 2 to the y is equal to 8 now, then I know y would be 3. Good wholesome numbers. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So that one works. Okay. So 16 worked, 8 worked. Let's try 4. If I plug in 4, and I'll change the color as well. 4 for x. That means I'm changing, saying 2 to the y is equal to 4. Well, 2 squared is equal to 4. So that would be 2. So 4, 2. That works. Then, since 16 worked, 8 worked, 4 worked, now I'm just going to plug in the luscious, the great, the grand, the wonderful 2. Because if I have 2 to the y is equal to 2, well, that's 1. So y is equal to 1. Okay. Now, if I'm looking at, and this is where the chart really comes in handy here, okay? Because I can always plug in 1. That's an easy one. Because if I have 2 to the y is equal to 1, then I know that y has to be 0. So 2, 1, that was my blue one. I'll color code that, sorry. The blue point right there. And then my red point, 1, 0 right there. Now, you might be tempted to stop, but I'm going to go a little bit further here. And then I'm going to look at my chart. Because 1/2, let's say I plugged in 1/2, and you might be like, well, Mr. Byrne, I don't like plugging in fractions. Yeah, okay. Not going to stop me, though. If I have 2 to the y is equal to 1 over 2, that's the same thing as 2 to the negative first power. So I get negative 1, which shows me that it goes below the x-axis. Okay, that's important here. And hopefully you look over here now. Every one of these values is getting to be a smaller and smaller fraction, but not negative. That means, if I could do this real carefully here, this line right here, this y-axis, will never be crossed. That means it's an asymptote, okay? It'll never be crossed, which means when you're graphing this, and you're graphing it very carefully, all right, I'll use a darker gray for this, that we can't cross it. We're going to connect all those dots. Ugh, come on, tighten up there, Mr. Byrne. This is our first logarithmic function. The other issue is we can't plug any numbers in here for x that are less than or equal to 0. You can't take log base 2 of 0. You'll get an undefined answer. So this is going to be our graph right there. Okay, 1 down, 2 to go. All right, so let me drop in my x and y. This is log base 4, so I've copied this chart in over here. Because really what we have here is y is equal to log base 4 of x is 4 to the y is equal to x. Okay, so we need to, if we have 4 to the y is equal to x, then I need to plug in good x values. So I'm going to start with 16. Why? Because 64, 256, 1024, and 4096 won't fit on our graph as x values. So I'm going to start with 16 here. If I plug in 16, what is log base 4 of 16? Well, that would be the same thing as saying 4 to the x is equal to 16, which is 4 squared. So 2 is what you get out of that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and up 2. There's your first point on this logarithmic function. Since I started at 16, now I'm going to go to 4. If I plug in 4, what is log base 4 of 4? Well, that would be like saying 4 to the x is equal to 4. And we know that 4 to the first is equal to 4. So that's going to be a 1 right there. Have to match. So for 1, we notice that this is a it doesn't have a lot of good points in it. Oh well. And hopefully you're realizing at this point, when I plugged in 16, I got 2. When I plugged in 4, I got 1. So then you can basically look at this chart and read it backwards. When you plug in 1, you're going to get 0. When you plug in 1/4, you're going to get -1. When you plug in 1/16, you're going to get -2. As many points as will fit. Anyway, when you're plotting those points, there's 1, 0 right there. Wait. I got it backwards, didn't I? Yeah, got to switch those two. And when you plug in 1/4, you get -1. When you plug in 1/16, you get -2. Sorry about that, everyone listening. There aren't many of you, but I do apologize. There's that one, and there's that one, even closer. But this graph is going to come very close, but never crossing the y-axis. It'll just be a very, very aggressive turn right there. I like the word aggressive for that. All right. And so that chart, got to have that. And hopefully this chart helps. Last example we're going to do is right here. I'm going to drop in my x and my y. And here I'm just going to use the chart. I can't do 27, but I'm going to start with 9. When you plug in 9, you get 2 out of it. When you plug in 3, you get 1 out of it. When you plug in 1, you get 0 out of it. When you plug in 1/3, you get -1 out of it. And then when you plug in 1/9, you end up getting -2 out of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. 9, 2 right there. It'd be fun to be 9, 2. No, I'm just kidding. That'd be miserable. There's 3, 1. There's 1, 0. And then 1/3 -1. And then it gets closer. So let me connect these using different colors so you can see it. Zoop. Now, I do know that I would have 27.3, but it doesn't show up on this graph. So that's as good as I can do. So those are your 3 graphs. Thank you for listening. Hopefully you've copied down the charts for each of them. If you can graph them, even better. Thank you for your time.